Go ahead.
We're ready. Give me a...
Hey, you're all set. Go ahead.
Let me thank you all for coming. Let me call to order our Thursday, May 3rd, 2012 Cape Cod Water Protection Collaborative Steering Committee meeting. This is a new experience for us on doing TV on this meeting. I know in my hometown, I'd rather not see myself on TV, and so I don't watch selectmen's meetings, but here we go. Can I have our first item on the agenda is approval of the previous meeting minutes? Is there a motion or comments on those?
I make a motion to approve.
Is there a second? All in favor?
Aye.
Passed.
I was not there, so I think I have.
Abstain, and I'll vote aye too, so we have a quorum vote on that. Will be approval of the minutes. The next item on member reports, I'd like to skip this morning because we have a full board, I think, discussion on item number 4. Andrew Goblick, who's obviously our executive director, called me yesterday and asked if he could be excused from this meeting. He has a family issue he needs to attend to. And so we'll leave the executive director report until next time. And I didn't check my email this morning, and so the fourth item on the agenda is a funding request from the town of Falmouth. And let me give you just from a quick discussion with Andrew yesterday. This is a request, generally speaking, that the collaborative spend, I think it's $6,000 to support the, what do you call the toilets that...
Composting?
Composting, the compost toilets. As I said, I was in meetings all morning, so I didn't get a chance to review that in more detail. I think I have some concern with that as a collaborative, we would be funding a specific type of action. You know, we're looking at strategy, and we have a full plate on looking at costing issues, on looking at how we help meet wastewater issues, and so I would rather not move in this direction of going of supporting a specific type of wastewater solution. Is my Gussie?
Yes, thank you, Mr. Chairman. I think I'm speaking closely enough. Thank you. It is my understanding, and correct me if I'm wrong, that at a town meeting, I think it was last year, they voted 2-point-something million to proceed to investigate a whole series of options for their wastewater, this being part of it. I don't know why they are turning to a county organization when those monies, and correct me if I'm wrong, were voted by their town meeting for investing in those options. And I think you're absolutely correct. And I do not think this is the kind of thing we want to pursue.
Okay. Any other comments or questions? I'm sorry I didn't get the email in time.
Only
Linnell?
that I would agree and be concerned about the precedent that we set. So I would agree with both of you.
Okay. Jane, any comments?
I'd really like to see a written proposal, but I agree with it would be targeted towards a specific technology, but I'd like to read more about what their proposal was, if possible.
Excuse me, Gussie.
Would you accept a motion that until further, unless they want to submit more detailed information, that we go on record as the steering committee to not be in favor of this proposal with the information we have?
I'd agree to that.
Then I move that.
Second. And I will forward that to you, presumably Andrew got it to me this morning, but been in meetings. But all in favor?
Aye.
Okay. The reason we're moving relatively quickly, and for those who just arrived, we've decided to televise these meetings, and the only difficulty that makes for the audience is that if you want to speak to us, you have to make the effort to get to a microphone. Not only so it gets on TV and they can view you on TV. hopefully that's not a handicap because we want everyone to feel comfortable talking. The fifth item on our agenda is discussion of cost factors in wastewater management. And as you may recall, we at the steering committee and as the governing committee a couple weeks ago asked that we look at not only this overall regional concept as being discussed, but we separate that into a series of problem statements just to double check that the solutions being proposed are going to answer the questions out there. And generally speaking, the questions fell into technical issues. We have some, I see Tom Kenrose keeps coming up from past of outfall pipes, for instance, no effect levels. We also wanted to look at specifically strategy of addressing costing, of how we could go after additional funding. And the fourth one was management. So those are the four sort of things we want to do to be sure that we're at the end of the year when we have our time frame that we're answering the questions in front of us. Mike Gigi is here today to talk to us about the costing part of that, which is probably the most important of those four items I mentioned, because that's getting everyone's attention. Mike, can I turn the microphone and stage over to you?
Okay, thank you.
And you can do a better job, I hope, of introducing yourself than I did.
Okay, my name is Mike Gigi from Wright Pierce Engineers, and I've been retained by the Commission to help in the formulation of the Regional Wastewater Management Plan with a specific focus on the cost aspects. So Andrew asked that I make a presentation today in terms of what we've been doing, what the current results seem to indicate, a status report, knowing that there'll be other discussions as the Regional Wastewater Management Plan gets developed. The goals of the costing effort at the Commission are these. We'd like to determine what the likely Cape-wide investment is in public wastewater infrastructure. We also want to make sure that whatever new infrastructure is looked at is compared with what residents of the Cape would be spending anyway for the replacement eventually of on-site septic systems. To help direct the effort, we're focusing on identifying the cost drivers, those factors that make the cost go up or allow it to come down, and using those to then formulate a program to contain the costs. So I'll present some information on each of these items today. We have a fair amount of information available to us. The Commission has a wonderful geographic information system that's at the heart of this effort. In 2010, the Barnstable County Cost Report was presented, and I'll summarize that for you today. We also have the benefit of a large number of technical reports from the Estuaries Project, and of course there's ongoing work by each of the towns, or many of the towns, with respect to comprehensive wastewater management planning, CWMPs. So let's start with an assessment of how big the problem is. And these are some numbers that have been presented in the past, but we've recently updated them. So I'm hoping that these now form the basis moving forward and we can treat them as gospel. Cape-wide, there's over 130,000 developed parcels. The water use is a little over 10 billion gallons of drinking water every year. Now that includes, most of that water is in the form of public water supply, but it also includes an allowance for private wells. So 10.7 billion gallons of water use, of which we think about 9.6 billion gallons becomes wastewater. Now, some of that wastewater is treated today. Most of it is disposed of on site, but some of it's treated. And there are 4 POTWs, publicly owned treatment works, including Falmouth, Hyannis, Chatham, and Provincetown. And there are some 50 what I call satellite plants, largely privately owned, but facilities that exist around the Cape for wastewater management. Together, those POTWs and satellite plants receive and treat about 1.4 billion gallons of wastewater every year. So that leaves the difference between 9.6 and 1.4 leaves 8.2 billion gallons that's now receives rudimentary treatment and disposal on lot. Let's look at that count of parcels in more detail. 133,000 developed parcels, 96% of which are residential. We've enumerated slightly more than 5,000 parcels that were called commercial, but that also includes industrial and everything other than residential. About 4,500 of those developed parcels Cape-wide are connected to those publicly owned treatment works and satellite facilities. So about 3.5% of the parcels that are on the Cape that are developed today go to some wastewater treatment facility. And the remainder, the 127,000, go to on-site disposal. And some of those, about 1,500, have innovative or alternative treatment systems. So about 1% of the on-site disposal is preceded by IA systems. We should be looking at the problem on a watershed basis. The key statistics are these. The MEP, Mass Estuaries Project, has completed technical reports on 35 coastal embayments. 11 more reports, or 11 more embayments, will be covered by future MEP reports, making a total of 46. So we're about 3/4 of the way through that process. Now, there are 11 coastal embayments where it's pretty obvious that there's no nitrogen impact. So you can add the numbers and see there's about 57 coastal embayments, 46 of which will be covered by MEP reports, 35 in hand. There are also 48 watersheds where the groundwater goes directly to the open ocean. And those are of some significant importance cost-wise, and we'll talk about that a little bit later. So you have 105 watersheds that we're basing our work on. 45% are direct ocean discharge. Unfortunately, those 45% of the watersheds only cover about 30% of the land area, another significant cost factor. So the question that I hear at least 3 times a day, okay, what's the cheapest way to skin this cat? And this is the premise that I put forth and the Commission has adopted, and that is, in most settings, I'm going to say that again, in most settings, the simple septic tank and leaching field is the clear winner. A lot of people say, what? I thought that was the problem. Well, go with me here. The avoidance of sewer costs, on-site systems require no sewers. The equivalent annual cost is fairly low. Once in every 3 or 4 years, they're pumped at reasonable cost. Title V systems require no day-to-day ongoing oversight. An occasional inspection is needed, of course. And there's no need to monitor them to show how well they do. So those factors together say this is a darn cheap way to manage wastewater. So one of the goals of the Regional Wastewater Management Plan, a very important one, is to maximize the use of Title V systems. I'm going to say that again because it causes people to scratch their heads sometimes. Maximize the use of on-site systems. Now, go back to my key words. In most settings, these systems are the clear winner. But let's look at the settings where they're not. Title V systems may not adequately address sanitary conditions where there's high groundwater or poor soils. They may not be protective of public or private water supplies. We all know that they're not at all effective with respect to avoiding nutrient enrichment of surface waters. And sometimes towns want more economic growth than Title V allows. And there are a handful of convenience and cost and aesthetic issues that make Title V systems less than adequate. Well, the big gorilla, as we all know, is number 3, avoiding nutrient enrichment of surface waters. So let's look at what the MEP reports have indicated. And one of the key numbers in any of the reports, if you have had a chance to look at them, is the septic nitrogen removal need. The MEP team will say, if you choose to reduce nitrogen load to that sensitive coastal embayment, and you choose to do it solely by sewering, it will tell you the percentage of the septic nitrogen load that should be removed to achieve the TMDL. Now, if that number's 60%, say, a town might choose to do less than 60% sewering and supplement that solution with some scattered on-site denitrification systems, some enhancement of embayment flushing, some fertilizer controls and the like. But the fundamental number is the one I'm presenting here. Of those 35 reports that are complete, the aggregate percent septic nitrogen removal is 54%. some numbers as low as 20, a number of them in 80 to 100% range, but the aggregate is 54%. So of the ones that are incomplete, the MEP watersheds that are not yet to be reported on, we based our cost estimates on an assumed 50% septic nitrogen removal. Now, the 11 that are not going to be studied by MEP, it's a fair bet that the nitrogen removal need there is 0. And it's also obvious that the nitrogen removal need in the 45 watersheds with direct ocean discharge is 0. You roll all those together, and this would indicate about 40% septic nitrogen removal. Now, I mentioned in an earlier slide there was about 8 billion gallons a year of wastewater discharged through on-site systems. Taking into account the geography, the location of those with respect to sensitive embayments, about 40% of that total needs to be subject to some sort of nitrogen control. How do you reduce septic nitrogen load? Well, we're approaching this as there's 3 possibilities, 3 broad possibilities. First of all, you can provide better nitrogen removal on-site, property by property, and I sometimes use the term on-site denites. You can collect the wastewater lot by lot, treat it, and dispose of it nearby in a satellite or cluster system. And by nearby, I mean in the same watershed where it was collected. Or you can collect it, treat it, and dispose of it outside the sensitive watershed, obviously at higher cost because you've collected more wastewater and you've transported it some distance away. The key question is, which one of these is the most cost-effective? Well, that was the question that the April 2010 report issued by the Commission with the sponsorship of the Collaborative addressed. So I'd like to take a few minutes and run through some of the conclusions of that report, because its goal was to answer the question, which systems are most cost-effective?
Mike, just a question. You know, everyone's taking notes here. I presume that we'll be able to put these slides up on our website?
Not immediately, but yes.
So we'll have this information
The
without...
set here today has some things that need to be addressed up, but yeah, in the next couple of days, sure,
Okay.
certainly. So the exercise that started in 2009 was completed in 2010 was to address these goals, to determine what has already been spent, to establish a uniform basis for comparing options, small and large, centralized and decentralized, to do a sensitivity analysis to determine some of the cost drivers, and to give a document to the towns that they could use to streamline their comprehensive wastewater management planning. The report was completed in 2010. I presented it to at least half the Cape Cod towns who had great interest in the results, and we're hoping that it has met these goals. So to make it simple, we looked at 4 types of wastewater systems: individual systems, the one where wastewater is treated and disposed of on the lot; cluster systems that are not large enough to require a groundwater discharge permit, but do allow taking the wastewater away from the lot to a nearby location; satellite systems, such as at Mashpee Commons, say, or the Horace Mann School in West Barnstable, Marston's Mills, and then centralized systems as exist in the 4 publicly owned treatment works. And we tried to be methodical. We looked at wastewater systems that don't rely on on-site disposal, the larger ones, to have these 3 components. In the nitrogen-sensitive watershed, there is a collection system. It leads to a wastewater treatment plant, which leads to an effluent disposal site. Now, in many cases, all 3 of those things occur in the watershed: collection, treatment, and disposal. But there's significant cost advantages to insert a transport function. That is, the best wastewater treatment facility site, remote from neighbors, industrial area, et cetera, might be outside the watershed, might be on town-owned parcels. And further, the best place to dispose of the effluent may not be at that treatment plant site, maybe somewhere else. And the transport costs are relatively small in the big picture, but very, very important if we're going to find the most cost-effective solution Cape-wide. So we started by doing a fairly detailed survey of wastewater experience on the Cape and in the Southeast region. We looked at 24 wastewater treatment plants of a broad range in size. We found out how much it cost to build them, and for most of them, how much it cost to operate them. It's all local data, and all the costs were adjusted to a common basis of late 2009. Very important curve here. Let me lead you through it. Across the bottom is the size of the wastewater treatment facility, small on the left, large on the right. And up the side is a the cost to construct a wastewater facility. And it's not just the cost, it's the unit cost. It's the cost per gallon of capacity. So on the far left, you see a number of $70 per gallon per day of capacity at a small facility, down to about 10 at a large facility. Here's some examples. The private facility that serves the Cotuit Stop and Shop is there at about $45 per gallon of capacity. The new Silver Beach plant, publicly owned, a little bit bigger, but a whole lot more expensive. You may recall some of the issues associated with that project's development and litigation and redesign. There's the municipal facilities in Provincetown, further down on the curve. Now, we did the same thing for operation and maintenance costs. Labor, chemicals, energy, the day-to-day, year-to-year operational costs. And we see a similar curve and the same sort of approach. The size of the facility across the bottom, the y-axis is the operation and maintenance costs in annual dollars expended per gallon per day treated. And there's the little satellite, actually cluster system in Orleans at Skakit Corner. There's the Mashpee Commons plant. Again, I'm working into larger facilities. There's the municipal operation in Falmouth. So these curves show two things. They show some scatter. Let me go back and notice the data points are not all right on the line here. There's lots of reasons why it's hard to predict what an exact facility might cost. But they illustrate economies of scale. The curve slopes downward to the right on those graphs. And what it means is the cost per gallon treated decreases as the size of the facility increases. Fundamental issue that anytime you've been at the airport looking to get into the city you've traveled to, are you going to take a cab at $20 or are you going to take a bus at $6? Well, the bus costs a lot more to buy than does the cab, but you can see how economies of scale is illustrated there. Here's some of the numbers from those curves. If you're going to build a wastewater treatment facility and it's 10,000 gallons a day, a small satellite facility, it might cost $70 per gallon per day of capacity. If it's 10 times as big, you've cut the cost in half per gallon. You've cut it in half again if you go to 1 million gallons a day. And similar trend for the annual operation and maintenance costs. In fact, even steeper. The economies of scale are more prevalent in operations than they are in construction. So, take-home message. Wastewater treatment costs are strongly influenced by economies of scale. I've underscored the word treatment for a reason, because the corollary to that is that wastewater collection costs, sewer costs, are not significantly influenced by economies of scale. Fundamental driver in the regional cost estimate here that we want to spend some time talking about. So to put some numbers on this phenomenon, we've come up with a new metric, a new measure. We've had the Commission GIS look at the length of streets in nitrogen-sensitive watersheds as an indicator or a measure of how much sewer pipe might be needed in that watershed. And we looked at the number of developed properties that might be served by that stretch of sewer. You take the two numbers, divide one by the other, and you get a measure of density. And that measure is feet of sewer pipe per connection, per parcel served. In my simple example, 1,000 feet of pipe might be needed in one neighborhood to connect up 10 homes and businesses. Well, the metric is 100 feet per connection. Very important measure of sewer costs, and we've been using the Commission's GIS to look at how these numbers vary, not just watershed by watershed, but neighborhood by neighborhood within watersheds. A clear effort to get to the heart of the cost for sewers. So I mentioned that the two curves I showed you before were pretty steeply sloping downhill to the right. Notice how flat this is. The cost up the side to serve one property is not influenced much by the size of the system that it's part of. Economies of scale are not significant at all. And 100 feet per connection is sort of what we've been using as a rule of thumb in doing some Cape-wide estimates. But look at what it is if it's a more dense neighborhood. The costs are virtually 1/2 as much. And if you happen to need to sewer neighborhoods that are much less dense, 150 feet per connection, they're that much more expensive. So there's very few economies of scale here, but a close correlation between the sewer costs and the density of the neighborhood that's served. Now, in measuring costs, the April 2010 report looks at 4 measures here. The capital cost, what it costs to design, permit, and construct wastewater facilities, whether it be collection, treatment, or disposal. What it costs, in the second case, to operate them, labor, power, chemicals, et cetera. And then a third cost measure is equivalent annual cost, a way to bundle together the capital cost and the operation and maintenance cost. So you can compare a high capital, low O&M alternative with a low capital, high O&M alternative. And you do it by adding together two things. The amortized capital cost, essentially the amount of your car payment. If you buy a car, how much are you going to pay the bank back every month? And the operation and maintenance costs, how much you're going to spend for tolls and gasoline and repairs. You can bundle those together into an equivalent annual cost, which is the best uniform measure of cost, better than capital, better than operation and maintenance. But we want to go beyond cost and look at effectiveness. These expenditures are primarily aimed at removing nitrogen. So let's look at how much nitrogen the given system removes. And if we bundle all these together, we can come up with a metric of dollars per pound of nitrogen removed. And the 2010 report uses that to compare alternatives. A real simple example here. Let's say there's a $31 million project involving some collection, satellite treatment plant, and some disposal. If you were to borrow money at 5% in 20 years, you'd be paying the bank back at $2.5 million a year. If it costs $500,000 a year to operate that system, you have an equivalent annual cost of 2.5 plus a half, or $3 million a year. And in this hypothetical example, the system is going to remove 8,700 pounds of nitrogen from that nitrogen-sensitive watershed. So you take the equivalent annual cost, divide by the nitrogen removed, and you get a new metric, a unit cost in dollars per pound. So the April 2010 report went forward and used this analysis to compare small and large systems of all different characteristics that are applicable to the Cape. Here's what we found. Some of the individual systems may cost $750 to $800 per pound of nitrogen removed. As you get larger, the economies of scale start to govern down to a central facility that might only be $300 per pound. So we're thinking, $300 to $800 as a range of costs. A very detailed sensitivity analysis was done to say, well, just a minute now, there's more to the subject than this, and indeed there is. We looked at all these factors. What if an on-site system can provide better nitrogen removal than it currently does? What if the discharge could be in a non-nitrogen sensitive watershed? What if regionalization was possible? A host of factors, I think 20 in total. And this graph intends to illustrate the results of that sensitivity analysis. And that metric of dollars spent per pound of nitrogen removed is across the bottom. Cheap on the left, expensive on the right. The top bar represents what we found for individual on-site systems, the next bar for cluster systems, the next one for satellite systems of two sizes, and the bottom for centralized systems. You see a broad range of cost depending on which option you select, and for many of the options you see a broad range depending on how that option gets applied. Look at the on-site DNITE bar there. The solid line through it is the $770 number we started with, but we played with factors and showed how that could be as low as $500 and as high as $850. Similarly, cluster systems, there's sort of the baseline number, but you can see how widely the costs varied about that. Similarly for two sizes of satellite systems. The numbers are much tighter for the centralized systems. But I must say that if you try to apply a centralized system to an area of very low density, that those bars would extend to the right significantly and eventually overlap the bars for individual systems. So thinking in terms of dollars per pound of nitrogen removed, $300 might be what, say, Chatham is experiencing. But look at where the numbers are. Collection, $200. Treatment, $65. Disposal, $25. Pretty important findings here. We're going to talk about them in some length. We tried to ground truth our evaluation by looking at specific projects. Indeed, you look at Chatham's numbers and it's $260 a pound. Provincetown spent $330. Some of the smaller systems like Mashpee Commons and Brackett Landing are up over 700. So it's a broad model, but it matches real-world experience on the Cape. And I'll invite you to look at the report in detail, but we said, okay, given these circumstances, what's the best case for on-site denitrification? What's the best case for cluster systems? What's the best case for satellite? And there's a lot of important information in the report in this regard. I would invite you to look at it in detail. But the best case for centralized systems is where you have dense development. I'm going to use that word dense a lot today. Dense development in watersheds where a lot of nitrogen needs to be removed. You've found town-owned treatment and disposal sites nearby, and by that I mean within 3 miles. The disposal site is not only nearby, but it's not in a nitrogen-sensitive watershed, very important factor. And you're located in such a way that Town A can reduce its cost by participating in a regional solution with Towns B and C. So, is there one answer to this question? What's the best solution for a town? No, it's not. And this report is meant to give town the ammunition to have some real-life examples and some cost data to apply to their circumstances to figure out what's best for the individual town. Now, commit this slide to memory. This is really important with respect to the rest of my message. You look at these different aspects of wastewater management when the management is not on site, and the typical collection cost is between 60 and 75% of the total. The treatment plant is typically 25% or less, and the disposal is not very expensive at all as a relative percentage. We're focusing in on these specific numbers for our analysis of cost drivers. We're assuming in the typical case that collection is 70%, treatment is 23%, disposal is 5%, and transport is 2%. So 100% of the project is typically going to be broken down as shown here. So what are the drivers? The density of development. If 70% of the costs are associated with collecting the wastewater in circumstances where it can't be handled on site, doesn't it make sense to minimize the costs associated with that 70%? And you do so by minimizing the length of sewer that you build per pound of nitrogen that you've removed. Economies of scale. The 25% number that pertains to wastewater treatment, remember the steepness of those graphs that I showed you? You can reduce costs by bringing wastewater together to have take advantage of economies of scale. Growth expectations, and I'll come back to this one too. If you decide you want to build wastewater facilities with lots of potential for future growth, lots of reserve capacity, it's going to cost a lot of money, disproportionately a lot of money, and I'll explain that in a minute. Location of effluent disposal. I said where effluent disposal costs are a relatively small portion of the total. They are, but the location of that disposal site has a strong influence on the rest of the costs, something we'll go over again in a minute. Development density. I mentioned we're starting with 100 feet per connection as sort of a baseline, but the facility at New Silver Beach, pretty dense neighborhood, that collection system is only at 50 feet per connection. Chatham averages 82. Augusta, the Orleans CWMP average was 138, reflecting some larger lots in the Pleasant Bay watershed. This is not a mistake. This is a printout from work the commission is doing from the GIS for actual watershed. And each of those squares is 40 acres. And the commission's GIS enables us to say what the average density is in that 40-acre grid. The dark squares are where that density is less than 100 feet per connection, typical of what you might see in Provincetown, for example, at New Silver Beach. The medium color is between 100 and 150 feet per connection. The lightest color is greater than 150. So remember what I said, we want to find a way, if we need to provide sewers, if on-site systems aren't going to be adequate in this setting, we need to provide sewers. Let's go to the dark squares. A lot of money can be saved. 70% of the total might be in this category. Let's work hard to find an aggregation of the darker colored squares so that we've reduced the cost per pound of nitrogen collected. Economies of scale affect not the collection, but the treatment. And we're doing some regionalization scenarios that involve, on one end, treating all the wastewater in the 4 existing treatment plants, expanding them to handle all of the Cape's flow. on the other end of the spectrum, looking at 13 plants, one in every town except Wellfleet and Truro. And look at how the cost per gallon treated vary. If every town does its own, we'd be looking at like $10 per gallon per day of capacity. If it was done at only the 4 existing ones, it would be about 35% less. And that 35% savings by economies of scale pertains not just to the construction, but also to the operation and maintenance. So are any of these real scenarios? No, but they're the basis for us identifying what the cost drivers are. Now, growth. Put yourself in a small watershed that's nitrogen sensitive, and this is just a hypothetical one. 100 pounds of nitrogen comes from septic systems in this hypothetical watershed under current conditions. UMass Dartmouth does its work, issues a TMDL and says, just a minute now, half of that nitrogen needs to be taken away if you're going to achieve water quality goals. So under current conditions, there's 100 pounds going in the ground through septic systems. We've got to find a way to remove half of that. Now, if we're savvy planners, we're also going to say, well, just a minute now, there's vacant lots in this watershed. The town may want to do some economic development, have a village center. What if this watershed grows by 30%? We had 100 pounds today, but 30% growth would indicate 130 pounds in the future. Now, the ability of the receiving water to assimilate nitrogen hasn't changed because of that growth. There's still only 50 pounds that can remain in the watershed in terms of septic load. So you have to remove the 50 pounds today and all of the increase. So the blue square, the nitrogen removal in the future condition, is 80 pounds. The 50 today and the 30 of growth. So if you look at just the nitrogen you need to remove, it was 50. With this growth scenario, it's now 80. A 30% growth resulted in a 60% increase in the amount of nitrogen you need to deal with. Is growth important? Absolutely. This example is summarized here. It's a 50% TMDL assumption, 30% growth in wastewater flow, results in a 60% increase in the amount of nitrogen you need to deal with. And you've learned that economies of scale mean that perhaps that's only a 50 to 55% increase in cost. But just think about this. 30% growth yields a 50% cost increase. Do you think that growth ought to be one of the factors we consider in our cost drivers? Absolutely. This slide summarizes the quality of nitrogen coming out of various systems. Tidal V in the 25 to 35 milligram per liter range, down to 3 to 5 milligrams per liter in central systems. We need to think about where that nitrogen is going. It's one thing to treat it, but we need to find the right place to put it. And I'm going to ask you to walk through this slide with me as an important example. We'll start with the watershed on the left in example A there. It's 1,000 homes on septic systems. The septic nitrogen load is 10,000 pounds. And Dr. Howes tells us that we've got to reduce that by 60%. So in the left-hand side here, we have a yellow box called treatment plant, happens to be in the watershed. But importantly, the effluent disposal is outside the watershed. So if you look at the numbers below, if we sewer 60% of the watershed, then there's 4,000 pounds of nitrogen left in the septic systems that remain, the top half of the watershed. There's no nitrogen associated with effluent disposal because we took it outside the watershed. And so we end up with only 4,000 pounds total in the watershed, and we've sewered 600 homes. That's the simple case. Now, what if we can't find an effluent disposal site nearby outside the watershed? It has to be within the watershed. We need to account for the fact that the effluent contains nitrogen. And if you work through the math on the right, you see instead of sewering 600 homes of the 1,000, we need to sewer 860, a 44% increase. Now that increase isn't as large if the effluent were at a 4 milligrams per liter. I used 8 in this example, but here's another cost driver. The location of the disposal drives the sewering costs. So even though disposal may only be 5% of the typical cost of a project, where it's located could increase the overall cost of the project significantly. Another cost driver is transport. And by transport, I mean moving from where you collected it to where you're going to treat it, but also where you're going to treat it to where you're going to dispose of it. And in the scenarios we investigated so far, this category of cost is less than 5% of the total. And it's a good thing, because if the transport costs are relatively small compared to what towns will be spending for collection and treatment, that means it's worthwhile to look hard, maybe at some distance, for wastewater treatment sites that are on municipally owned land, or most importantly, for disposal sites outside of nitrogen-sensitive watersheds.
Mike, can you refine that a bit, the difference between transport and collection?
Yes, and thank you for going back to that. By collection, I mean getting it from the house into a public sewer. And so you have a neighborhood that's sewered, but then you need to transport that collected wastewater to the treatment plant. So collection is the sewers in the street in the residential neighborhood. Transport is pumping it to the treatment plant and then pumping the effluent to disposal. So those categories are, it's an important categorization, and the fact that the transport costs are relatively small means that there's leverage here. You can maybe selectively increase your transport costs to find the disposal site that's outside the watershed to avoid the added sewering costs if you don't. So if we're going to control costs, what should we do? We should look very closely at growth. If we can limit flow increases, growth, to non-sensitive watersheds selectively, excuse me, let's say that again. If we can limit nitrogen loading in the future by causing our growth to occur in non-sensitive watersheds and preventing it from sensitive watersheds, we'll save some money. The sewering costs could be the biggest part of the overall project, so clearly look at the densest areas, and if you need to provide nitrogen control and it's not a dense area, then home in on individual denitrifying systems. And to keep sewer costs down, be savvy in where you locate your disposal site for the reasons I mentioned. Economies of scale are important on the treatment side. There's significant amount of cost that can be saved by expanding existing publicly owned treatment works instead of building a large number of small new ones. Location of effluent disposal, another major driver. Clearly you want to avoid zone 2s where treatment costs are greater because of the need to remove other contaminants of drinking water concern. And if you're hoping to reduce the residual nitrogen staying in the watershed, then in the circumstances where you may want to stay away from on-site denites because that nitrogen stays in the watershed. So this is a status report. We hope to issue something in writing this summer to summarize some of the information that you've heard today. And I agree, Larry, there's a lot here, and we need to have multiple steps of public presentation and feedback. There's a great deal of information here, and what we're doing needs to be informed by the opinions and thoughts of a broader group. So the report will predict what Cape-wide costs could be, not only for new infrastructure, for what would be spent even if no infrastructure is built and we continue to rely on Title V systems, and it will have a fairly detailed cost control program to keep a big number as small as possible.
Are there questions for Mike?
Oh, yeah, I do. Thank you, Mr. Chairman. Gussie McCusick from Orleans. I'm trying to read my notes, and you said that 50% of the nitrogen needs to be removed according to the MAP studies. And then you said that 39% of septic nitrogen needs to be removed. I'm trying to get a percentage of when this is all and done and everybody's met their TMDLs. Will we have the ability to go with Title V systems in 60% or 50% of the Cape?
Okay. Let me take you to that specific slide, Gussie, so there's no confusion.
I have a follow-up when I get that good number.
We're getting there. Okay. That in the 35 watersheds where reports are available,
50.
the grand average is 54% septic nitrogen removal. So let's pick a typical one at 54%. In that watershed, if a town or aggregation of towns should choose to use sewering to remove that nitrogen, in simple terms, it would collect wastewater from 54% of the homes and businesses, take it outside the watershed, and 46% would remain on Title V, in that simple example. But as you just heard, if we can't find a disposal site outside the watershed, then it needs to be more than 54%. It might have to be 60 or 65%. So that's in a case where we have a TMDL in place and it shows a 54% septic nitrogen removal percentage. If you look Cape-wide, there's places where it's 0. So real simplistically, the bottom line here, the 39%, that says that if we're savvy in finding disposal sites, that we should be able to allow about 60% of the homes homes and businesses to stay on Title V.
Great. I need to get a ballpark, and I realize every town is different. But that being the case, have you factored in here, particularly when you're looking at apples and apples, the need for sludge removal from these treatment plants? Have you factored in here the costs of pumping the septic tanks, the septic waste? Because that's still going to have to be done.
I mentioned the basic elements of collection, treatment, and disposal with some transport in there. Those form the core of our estimates for cost, but we've added in allowances for a host of factors: the purchase of the land, the engineering costs, legal contingencies, septage management, pumping, all of those things. We're trying to be as holistic as possible. So I didn't present anything today in that regard, Gussie, but the final estimates will include those.
So a town will, in all likelihood, have to provide some place for the treated wastewater as well as the sludge and the septic pumping.
Correct.
Thank you.
I'll go next, and there's someone else. Now, are you ready? Thank you, Mike. It was a good
Great.
presentation. I guess my questions are more directional, and that is, I'm trying to get a handle on the the advantages of a regional approach. We've sort of taken that for granted, but as the economist would say, it all depends on what goes into that. And I'm wondering, with the information or moving forward, what's the best approach of going from sort of the averages you're talking about Cape-wide to the specifics? For instance, in Harwich, we're actually addressing most of these issues now in the sense of, we're concentrating on the most, and Dave's here, so he'll yell at me if I get anything wrong, but we're already looking at the most dense areas for the collection costs are. We're working with Chatham. Hopefully we will be able to hook into their sewer because of the figures, it reinforces the numbers you gave. The problems we're having is one of the biggest problem is disposal site, where we do that and how will we factor in the cost of moving that around to different places. The other thing I'm interested in, are there cost advantages in addition to what you put out in terms of management issues? If we were to, share a water district with Chatham, for instance, does that save us? Is there some costs or some reasons for doing that? In addition to separate, so that we're taking advantage of those. But
let me take your second question first, Larry. Are there management cost savings as well as other technical costs? And indeed, and the operation and maintenance costs that I presented here include the fundamental things like labor and benefits and chemicals and energy and the like, but it also includes the management staff. So if you have 2 treatment plants in 2 towns, each with a wastewater superintendent, versus 1 town that serves Harwich and Chatham, you probably only need 1 superintendent. And so there's a great example of economies of scale, and that sort of thing is included in our evaluation.
Yeah.
Now, to get to your first question, look at my typical cost distribution in this slide, and put on your regionalization hat. So, are you is regionalization apt to save much with respect to, let me do treatment first? Well, yes, economies of scale. I showed with 4 treatment plants versus 13, there might be a 35% savings in construction and operation and maintenance. Ask the same question about collection. Is regionalization going to give you much with respect to collection? The simple answer is no. However, if in a given watershed,
It may help us, it may help us in finding the best disposal site.
I'm going to go there next, but think about this. I'm going to use two towns near and dear to two hearts here, Eastham and Orleans. We looked at what might be saved in a regional facility involving those two towns. And the simple thing was Eastham would collect its share of the wastewater to deal with its share of the Nauset need, and Orleans would do the same. But we also said, it might be savvy if some of Eastham's need was solved by sewers in Orleans. So either side of Town Cove, but if there are neighborhoods in Orleans that are more densely developed, that's where a regional effort might point you, as opposed to each town just looking for its most densely developed neighborhoods. Look at the most densely developed neighborhoods across the watershed. So there's a case where regionalization, on the face of it, you'd think there's nothing to be saved there, but there's an example where it would. The indirect savings on collection are what you noted. If you can find an effluent, say there's no effluent disposal site in Harwich that's outside of sensitive watersheds, but there's one in Brewster or Chatham, then you have directly impacted significantly the collection cost by finding that site. So regionalization, on the face of it, wouldn't say much for collection, but I think it's probably one of the areas where it has the most leverage, the most advantage in terms of saving costs.
Okay. Other questions?
I have a question.
Jane?
Yeah. Did you consider cost savings of regionalizing management of IA systems through a sort of a common entity that might be able to reduce costs to the individual property owners by, a collective effort?
Yes, we did, Jane. And if you look at the top bar here, remember this again is the dollars per pound of nitrogen removed, and see how long that bar is for individual nitrogen removal systems, going from 550 to 850 pounds. Some of the scenarios, and I'll point them here, if you see the G, the F, the E, and D, those scenarios looked at different sensitivity factors. And one of them was significantly reducing the management aspects of, you have a collective system for managing a large number of IA systems. And I'm not sure which one of those it was, but it had a significant impact.
Now, before I get to you, let me just build on Jane's comment, because, to me, that's an important issue. In a broader sense, is that we seem to have gotten into a public discussion of, is it good or bad to have the county-controlled regional wastewater? And we're not even sure we're going there yet, so we're kind of discussing an endpoint that's not even resolved. But I would certainly like to turn that discussion around and have that not be the issue, but the discussion in my mind should be, how can the county help us meet our water quality requirements? And that's a different discussion, because that brings in, and I'm putting this out for people hopefully that will watch this, and that brings in more questions as Jane had is, that'd be are there other things the county can be doing to help us on these cost factors outside of that general discussion of, if you will, regionalization or not? What can you be doing to help? What's the input on that? I think that would change not only the tone, it might give us a more productive outcome.
Yeah. And everything I've said today, I hope, has been focused on, let's figure out what drives the cost and find ways to save it. I haven't said anything about who ought to drive the cost.
Right.
And that's a discussion that is beyond my skills and capabilities.
And I don't want to go there either, but I do want to just open it up that I think we're all looking for suggestions of how to do it better and how we can help each other. Linnell?
Mine's a very simple question. You made a statement. Well, first of all, thank you for making such a good explanation about the impact of Title V's and the consideration that Title V's are not going to be eliminated in our overall planning, which is something that, I'm well aware of in Sandwich. We're a year into our comprehensive water resource management plan. But I think 3 years ago, the collaborative, I think it was 3 years, or maybe 2, sponsored an excellent, which I believe you were part of, workshop, all-day workshop, That was the first really public presentation that we're not looking at sewering one end of Cape to the other. We're looking at taking a combined approach. So thank you for that good explanation. That is something people still don't quite understand. Some people still think that a regional plan is talking about sewering one end of Cape to the other. So the more we talk about that, this will be a multi-remedy approach. But you made the statement that Title V systems aren't monitored, and it just brought a real simple question for me. Should we be thinking about that? Because regardless of the legality of how the Title V impacts and the monitoring of them, you know, as we look at regional planning, should we be really realistically looking at, is that something that needs to be considered in the future to take better care of the water quality?
Well, if we're going to hope to have half or more of the homes and businesses on Cape Cod continuing to rely on Title V systems, clearly we need to have a program to optimize that, to reduce the frequency with which they need to be upgraded.
Right.
And that's, in fact, the subject of a meeting that I'll be in this afternoon at 1 o'clock, that very subject.
Go ahead, sorry.
But the monitoring point I made is that, and this will kind of tie together what Jane just asked, one of the fundamental reasons why the top bar in that graph is to the right, why costs for on-site denitrification systems are relatively high, is in the setting, in fact, I use the words, the upper right-hand corner, for TMDL compliance.
Yeah.
If you're going to use these systems to say to a third party who's might be in litigation, or DEP or EPA to say, yep, we met our TMDL, you have to show people that you did that. So if you have 200 individual denites all across a given town, you got to measure the quality of the effluent to say, yep, we did it. You thought you were going to get down to 17. Whoops, I'm only at 20. So that was what I meant when I said monitoring. With a Title V system, everybody knows it's not going to provide any nitrogen removal of significance, so you don't bother to measure it. So there's not the day-to-day monitoring to show that you've met a TMDL. That's what I meant when I said
And I
monitoring.
think that then a follow-up to that would be then the public, their understanding of Title V as an independent way to deal with their wastewater. And how do we educate them that there's still no risk to the overall watershed issues? Because I think that people could get confused by, you did a really good job at the beginning of this talking about this is a concept people are still wrestling with, but I think that it has a financial complexity to it as well. So people, how do we in the towns talk about the Title V issue as part of our planning process, but not necessarily as part of our remedy process?
Let me just comment briefly, because I have a cautionary note. Is I've had people come to me and say, well, that one approach of attacking this is to, in fact, put in stronger regulations that we pump our septic tanks, every other year, so we get out of the nitrogen issue. So there's, I think we've been too involved in it, but there's still confusion that we need to continually educate people that we can't do something, we can't dump this on the Board of Health and say, okay, just, toughen up and we don't have to worry about it.
Thank you.
The best
You're
illustration
getting to
I
my point.
have of the complexities and the importance of public education, I made this comment earlier, and I saw 4 sets of eyebrows go up on 4 people that are pretty knowledgeable about this situation. I'll repeat my comment. Septic systems are the problem, but we need to use them wherever we can.
Yeah, exactly.
And I saw 4 eyebrows rise right when I said that, and it's kind of counterintuitive, but
Well, the part that is kind of distressing, I mean, the point about information education is key. And this alone is a piece of that. This is good. I'm glad we're on TV. But it is not only counterintuitive, I think it can work against our winning people to the side of thinking, let's plan and finance and fund for the future. So that's just a concern. There's not really an answer for it in this, in this meeting, but the eyebrows go up because that you put it really well. I mean, that's a very honest way to put it. But how does that come across in terms of the things that we're facing in terms of, where our town people are concerned and their difficulty with the financial piece of this?
This may not help, but I heard Maggie Geis once say that the Cape didn't have a wastewater problem back in the 50s because the Cape was X big and the waters were able to heal themselves. Yes, the septic systems or maybe even outhouses then were draining but it was able to keep in balance. And what has happened to this Cape since 1950 is all that watershed that has had the growth and now has doubled and tripled. So we have outstripped our sustainability factor, which helps me understand it.
And talking about, just one last follow-up, the financial piece, because what we're going to be facing in the conversations we have in our individual towns, and when we bring articles to town meeting that cover wastewater, will be the cost factor. So if, regardless of the reality of, septic, we need to use it, but they're part of the problem, we still need to find a way, and I think I didn't hear you talk too much to this, but I liked what you were talking about, comparing the cost for remedy, let's use that word, to the cost that's being spent today to deal with wastewater. We haven't talked about that, but that I think is a really important figure, because that's what gave me a little hope. If people see what we're spending already and we're not getting anywhere, and then this is what we can spend to make sure that we take care of this and there's not going to be further degradation to the water, then I think we have an argument. So it all, it is an evolution of education and also the way we present it. Thank you. This has been helpful.
Very helpful.
And I think your comment about the septic tanks, the corollary of that is that we don't have to sewer all of the Cape Cod, nor should
Right.
we. And so they kind of explain two sides of the same story,
Yep.
which is good. Jane?
Just one further expansion on the Title V systems. Mike, did you look at all at the number of lots where there aren't even Title V systems, where the standard exists, where Gussie's we're talking about cesspools that weren't even designed to any engineering standard, where there might not be separation of groundwater, so we're not even getting that 25% reduction that we're seeing in the newer code systems pretty much across the board. So that's still going to be a problem in communities where you have the 40% Title V systems remaining in place. That will still be an issue for towns to address, the upgrade of substandard on-site cesspools or overflow cesspools, whatever they
Jane,
might be.
you've seen the agenda for the meeting that I'm going to next. That's one of the topics we're going to discuss. Partly prompted by a statistic I heard from Orleans that I think I heard, Gussie, that as many as 900?
We calculated that 18 to 20% of our residents still are served by cesspools.
I didn't know that.
It's a scary number. And then we looked at all of our IA systems we put in our Board of Health, and I've been on it for longer than I care to admit, has been very reluctant to allow an IA system to go in. But we looked at their compliance with all the regulations, and not even half of them were meeting the requirements, which is concerning if you have IAs.
Let me ask, we have a few people in the audience. Any questions, comments? Mr. Young, you're working with Harwich. Do you have any questions or comments you'd like to add to this, or am I putting you on the spot?
Good afternoon, David Young, CDM Smith, doing wastewater planning in Harwich, as Larry indicated. Mike has done another nice summary of different cost factors, drivers in wastewater planning. I guess just one comment I would make is that, from my experience, 5% for accounting for the effluent recharge, I think, is on the low side. Typical 70-30 split, yeah, that's probably right on the mark. but that treatment, if you compare treatment versus the effluent recharge, the two can't really be split out. They are connected at the hip. What I mean by that is level of treatment required depending on where you're recharging, how much nitrogen are you removing, how far away is that effluent recharge site to pump to. It's one of the things that has negated some of the regionalization in analysis that we've looked at, where the effluent has to go back to different communities or outside of that watershed. When you try to take advantage of the economies of scale of building a larger wastewater plant, that sometimes brings out the negative factors of effluent recharge. Groundwater impacts, being able to put too much nitrogen back into that watershed, or having to then increase the sewer system within that watershed. All those factors come into play. And so I think just being in the 2 to 5% range for effluent recharge, to me, it's probably on the low side. But
Thank you, Dave. And, Mike addressed that sort of indirectly by zone twos and how we have to go back to and recharge, but that's a good comment. Does anyone else want to, if not, thanks again, Mike, and you're going to have to get out of here and eat and go to your next meeting. So I'm hoping that we'll have a chance to see this on the web, and we'll get in front of our governing committee, so we have a wider view on that. We do have folks from Cape Cod Commission here, and I thanks for attending. I hope that you'll continue to work to get as much broad input as you can into these discussions. We want to be sure that we bring everyone's involved, so we get to a positive outcome. And I'm looking forward to. We have three other, as I mentioned at the beginning, 3 other items that we want to discuss, and that we have a chance to address those as well, so that people are comfortable that we're at the end of the, I was going to say end of the day, it's the end of the year, when our deadline is, that we're coming to the right solution, and we're bringing people along with us at the same time. I think we all would like to move away from the sometimes acrimonious debate and get on with life, and so I appreciate your help. Are there any other discussions? I think we've had a good and relatively efficient meeting. I'll move to adjourn. Anyone?
So move.
Second.
All in favor?
Aye.
Thank you.